Hi guys, my name is Harry. In this video, I'm going to go through the Additional Mathematics SPM trial paper year 2021 for Johor paper 1. Okay, let's begin with question number 1. This question is from Form 4, Chapter 1, Function. So here we have function g that is defined represented by gx equals to ax minus b, where a and b are constant. You're given that the image of -3 is -21. So when we say image of -3, that means we put -3 inside. The result is -21. At the same time, object of 4 is now 2. Now be careful with this. Object of 4 is now 2. That means if you put 2 inside, you will get 4. Now, object of 4 equals to, meaning 4 is your image or your y value, 2 is your object of or your x value. Yeah. Okay, object of 4 is 2, that means G2 equals to 4, not G4 equals to, not the other way around. So here we have a pair of information and we have to sub inside your function here. Like for example, the first one, we put A, multiply -3, we minus B, the result is -21. Now, you can leave it. You want to make B as a subject, also can. So I'm just going to leave it as -3A. Yeah, -3A minus B equals -21 and call this equation 1. Whereas for the second one, I take A times B, A times 2 minus B equals to 4. In fact, you don't have to write A times 2. You can just rewrite 2A. 2A minus B equals to 4, equation number 2. Now let's take equation 2 minus equation 1. Here I'm using elimination. 2A minus 3A. Yeah, it looks like this. 2A minus 3A is going to give us 5. Minus B minus B minus B is going to cancel out. So you get 5A equals, and this is 4 minus 21. 4 minus 21, it is going to give us 25. So my A is just 25 divided by 5. A is just 5. And if you want to find the value of B, we can just sub inside any equation. Here I sub inside equation 2. 2 times A is 5 minus B equals to 4. So 10 minus B is 4. Bring over. Yeah, bring the B over here. Negative B, bring over becomes positive B. 10 minus 4, B is 6. Okay, let's continue with part B. You're supposed to find the object that is mapped onto itself under the function v. Now that I know my A is 5, my B is 6. An object is mapped onto itself when your image gx is the same as your object x. So here we let 5x minus 6 equals to x. Let's bring this over, 5x minus 1x is 4x. -6 bring over, you get positive 6. X is therefore 6 over 4 or 3 over 2. Yeah. So meaning when you put 3 over 2 inside, you will get 3 over 2. Yeah. So that's the meaning of object that is mapped onto itself. In this case, x is 3 over 2. Moving on to question number 2. This question is also from function from 4 chapter 1. Here you're given a diagram that shows the graph of gx equals to square root x minus 3 for x between 3 over 4 and 3. So hx is the image of gx under the reflection in the line gx equals x. Yeah. Maybe they should say y equals x because it's a bit confusing. But here, because there's a gx here, this is gx here, this is gx here. So normally we just say it's y, right? So anyhow, we need to find hx. So hx, when you reflect in the line y equals x, right? We know that hx is the inverse of gx. Yeah. When you inverse a function graphically, the inverse function is a reflection of the original function in the line y equals x. So what we need to do is to find g inverse, right? So we start off by saying g, we let g inverse x becomes y, because your h is your g inverse, right? So your gy is now x. Okay, just so you know, because some of you may use this gx equals y. If you let gx equals y, you need to make x as a subject. if you let G inverse X equals Y, you need to make Y as the subject. Okay, just a different way of doing. So, and I hope you know that Y, how do you go from the first line to the second line? For example, this is X. When you inverse a function, let's say you get Y. So when you move forward, we start from Y, you would get X. Yeah, GY is now X. So let's take this and sub inside your G here. Square root of 4Y minus 3 is now X. Let us square both sides. So you get X squared. Let us bring the negative 3 over. You get X squared plus 3. And finally, divide by 4. You get X squared plus 3 over 4. And your Y is your G inverse, right? Which is actually your HX, okay? Your HX is the G inverse. So I think I'll just write HX straight away. It is X squared plus 3 over 4. All right. Then you're supposed to find the domain of the function H. Now, remember one thing. When you inverse a function, the domain and range will now interchange. Originally, for Gx, your domain is given. This is your domain. All right. Now, you can actually validate when we put 3 over 2 inside your original function G. Okay, this is part B. When I put 3 over 4 inside, you will get 4 times 3 over 4 minus 3, which gives us 0. You can see from here, this is your 3 over 4, and your Y value is 0. When you put 3 inside, you get square root. 4 times 3 minus 3, 12 minus 3 is 9, square root 9 is 3. That means my Y value is 3. That means we know for Gx, your range for Gx is between 0 and 3. Okay, so when X is 3, your Y is also 3. You can see from here. So for original function, this is your domain, and this is your range. The moment you inverse it, this one is now your domain. The green one is now your domain. The range of Gx is now the domain for G inverse X, in this case, your Hx. So we say for Hx, right? Your domain is X between 0 and 3. That's all. Yeah, remember, the domain of your inverse function is the same as the range of your original function, because once you reflect it, right, the domain and range will now interchange. Okay, last part, C. G, H, P over 2. Okay, see, you can see this is only 3 marks. Actually, you don't do a lot of working here. All right, in fact, the first one we can actually do shortcut. We don't have to do so long because it's 1 mark for each answer. So you can just do this mentally. You can just do this quickly here because it's 1 mark for the final answer, this one. All right. When you have G, H, P over 2, we know H is your G inverse. So G inverse P over 2. When you do G inverse followed by G, you can see from this diagram here, when you do G inverse followed by G, you will end up at the same place where you started. So generally, whether you do G inverse Gx or G inverse X, it will always map onto the original value. Yeah, so you always get back X. So likewise, this answer is just P over 2, because G inverse means you go backwards, Gx means you go forward, so you end up where you started, which is P over 2. Okay, this is question 3, is Form 5, Chapter 4, Permutation and Combination. So here we have a 10 scouts, which consists of 6 boys and 4 girls. They sit around a campfire. Find the number of ways to arrange them if there is no restriction. Okay, so sometimes you know they say around a campfire. Yeah, now maybe you should add, see, mengelilingi sebuah unggun api dalam satu bulatan, ya, around a circle. So we know, or in a circle, should I say, in a circle, in a circle. So we know it's a circular arrangement. Yeah, for circular arrangement, right? If you have no condition, right, you have 10 people to sit in a row. So I hope you understand, or maybe I explain quickly the idea. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you arrange them in a row, it's basically 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So the number of ways is just 10 factorial. But let's say I take the first and the last and then I tie them together. So what happened? It now go in a circle like this, where you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They join together. For example, the first person is A, next one is B, C, D, E, F, G, H, I, J. So A is here and J is here. Now the problem is, what if I start with B and I end with J followed by A? So when I tie them together, I'm actually getting the same arrangement. It's just that my B is now here, right? A is now here, J is now here, C and D and so on. So it's now what happened is I've already moved the position of A. So A, instead of starting in the middle, I can start from here. But they have the same arrangement because A would have the same person seated next to him. Like you will see, have B seated on the left, J seated on the right. Same goes to this. Yeah, A seated has B seated on the left, J seated on the right. So, and there are 10 different positions I can put A that actually result in the same arrangement. For example, I can put A here, I can put A here, 3, 4, 5, 6, 7, 8, 9, 10. So that's why when it comes to circular arrangement, number one, we have to consider arrangement in a row first, in this case 10 factorial. Then we got to divide by 10 to cancel out the same arrangement in a circle because A has 10 different positions I can put them. All right, the same goes to B and C and D. So that's why we always have to divide. Like if you have n factorial, you got to divide n. Sometimes you can just write n minus 1 factorial or just write 9 factorial will do. Okay. All right. So you don't actually have to write all these, draw all these boxes, right? So I just want to explain to you the idea. All right. You understand? So 9 factorial will give us 362,880. 362,880. So we don't have to do all these things. Just straight away write 9 factorial. Or if you want 10 factorial, you write 10. Yeah, equals to 9 factorial, which is 362,880. Okay, I think the second part, right? The terminology that they use is a little bit, how would I say, unsuitable. Should we say, all the boys cannot be seated together? Cannot be seated together. Yeah, and if you check the marking scheme, it is also based on this. Because why do I say that? But when we say all the boys are separated, means what? The boys, no two boys next to each other. That means you can have a boy, you can have a girl, you can have a boy, you can have a girl, you can have a boy, you can have a girl, you can have a boy, you can have a girl. Now here's the problem. You have 6 boys and 4 girls. Is it possible to separate all the boys? Answer is no, right? Because you see, you only have 4 girls, right? 1, 2, 3, 4, then 5 boys. So where do you put the 6th boy? Here? Then they are no longer separated, right? So what the question actually wanted to say is that all the boys cannot be seated together, right? If you check the marking scheme, it is actually solved using this. Yeah, all the boys cannot be seated together. So if all the boys cannot be seated together, means what? You can have 2 boys together, the rest separated, 3 boys together, the rest separated, and so on, right? So the key is to take total minus putting all the boys together. Now, using the idea of complement, if this is event A, outside here is your A complement. This is your universal set. So if I want to find the number of ways A complement occur, I take n, your universal set, or we say ns. In probability, we say ns minus na. So that means we find out the number of ways they are all together. Then we take total minus they're all together to find out the number of ways they cannot be seated together. Well, we already have the total. Part A is your total. This represents total. So part B, what we do is, let's find out how many ways you can put the boys together. Since there are 6 boys, 1, 2, 3, 4, 5, 6. we tie the boys together as a block. So there are 6, 5, 4, 3, 2, 1, or 6 factorial ways to arrange the boys. Now I still have 4 more girls, right? I still have 4 more girls. And how many ways to arrange the girls, the boys and the girls? Now remember, we need to treat the boys as a block of boys. They are together, right? If one goes, all of them must go together, right? So what we should do next is to arrange these 4 plus 1 block, 4 girls plus 1 block, which is 5, 4, 3, 2, 1, which is 5 factorial. Yeah, remember, we have to treat this like a block itself. So there are 6 factorial times 5 factorial ways to represent the number of ways the boys are together. All right, so let's do this. 6 factorial multiplied by 5 factorial, it gives us 86400. 86400. So boys not together, in this case, is your total 362880 minus boys together. Okay, let's count. 362880 minus this answer, 27. Okay, wait, let me counter check. I forgot to divide. Wait, because we need to arrange them in a circle. Sorry, we're going to divide by 5 factorial. 5. Why do I divide by 5? Okay, this one we are putting them in a row. We haven't put them in a circle yet. So there's a block of 5. Let's say, let me draw like this. The 6 boys are together. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4. Can you see the girls? And we tie them together like this. But remember, the boys can sit here, can sit in the second position, third, fourth, fifth, which gives us the same arrangement. That's why I have to divide by 5. Or we can say 4 factorial. So let's take this answer, 6 factorial. You can straight away multiply by 5 factorial, because 5 factorial divide 4 factorial, because 5 factorial divided by 5 is just 4 factorial. So this gives us 17280. 17280. So let's do boys not together. That will give us 362880 minus 17280. Okay, let's count. 362,880 minus 17280. This gives us 345,600. 345,600. All right. Okay, question number 4. Okay, in this question, we have to use this is a probability distribution from 5, chapter 5. 98%, the first part, 98% of the students in school were chosen at random. The probability that all the students chosen, 98% students in particular class attended curricular activity, right? A group of students chosen at random, probability that all students chosen attended curriculum activity is more than 0.6099. Find the value n. Yeah, where n is the total number of students in a class. Okay, so let me do it over here. So the first thing, this is a binomial, yeah, it's a binomial distribution. You don't write this, is fine. Where n is an unknown. N means you're choosing n student, right? Out of a group of students in a school. All right. And the probability that a student attend curricular activity is 0.98. Yeah, 98% in probability is 0.98. Now, when you randomly choose n student and they say all of them, right? All means all n of them attended curricular activity is now more than 0.6099. So remember, for probability binomial distribution, your probability x equals to r is given by NCR p power r q power n minus r. So here, my formula is NCN. P is 0.98. Yeah, probability that they attended curricular activity. Q is 0.02. Now remember the relationship between P and Q. P plus Q is 1. Q is 1 minus P. As we take 1 minus 0.98, you get 0.02. And this is N minus R. Since your R is N, you get power 0. And this number should be greater than 0.6099. Now we know NCN is 1. And this is 0.98 power N, right? 0.02 power 0. This one is 0.6099. So what I need to do to solve for N is to introduce logarithm on both sides of the equation. Now let's bring the power down. N LG 0.98 is now greater than LG 0.6099. Then you divide them. Okay, as you divide them, you have log 0.6099. You divide by log 0.98. Okay, now remember, when you divide a number, when you divide a negative number or times a negative number, your inequality symbol has to change. You can see from here, I changed my inequality symbol, right? Now, sometimes you can't see it because you maybe you need to type it out, right? Like for example, when I divide like this, you can't see whether this number is positive or negative because I divide directly. Yeah? So this is 24.47. Let me write it down first, 24.47. If you're unsure, you can just type log 0.98 here. See, this is a negative number. And let's say I do log 0.6099. Notice this is a negative number. So a negative number divided by a negative number is going to be positive, but the symbol has to change. And your N is now 24. Yeah, you are finding, in this case, you're finding N. Now, the question mention more than. So actually it's a least the maximum value of N. N is supposed to be a maximum value. Yeah. So if it's less than 24.47, N must be 24. For part B, right, we need to use a mathematical table to find the value of N. Now here, we are given Z is a continuous random variable of a normal distribution. The probability of modulus Z less than M is 8 times modulus Z less than negative M, less equals negative M. Okay, so let's do a sketch. Now, I do not know where is M, all right? So maybe M is here. So negative M will be on the left here. Now, probability of modulus Z less than M. Okay, I hope you know that when you say modulus Z less than M, when you open up, there is a positive and negative, right? So that means there is a negative M and a positive M. So negative, when you open up, you're going to change the symbol. Positive, you maintain the symbol. So in this case, your Z is between negative M and M. So when you see that they say the probability of Z less than M, we are modulus Z less than M. We are referring to this part. All right. Okay. And this is 8 times of this part. This is a probability of Z less than negative M. The black part is probability of Z, modulus of Z in between M, right? So maybe we can say, this maybe I can let P Z less than negative M. It is the same as P Z more than positive M because we can reflect this over. The pink part and the orange part, they are actually the same, right? And let's call this P. Now, it is given that this is 8 times this region in between here, the black part, is 8 times of this. Yeah, looking at this, we say that if this is P, this modulus Z less than M will be 8P. And if you add up, this is 1P here, this is 1P here, this is 8P here, your total is going to give us 10P, right? So if 10P is 1, P is 0.1. And what is P? P is the probability of Z. You can either write less than M or less than negative M, or you can say more than M. So here I'm going to use more than M. I'm going to use more than M. and the result is 0.1. But look at what we're finding. We're finding the probability of z less than m. Less than m, meaning we are only finding this part. Now, since the upper tail here is 0.1, the lower tail here should be 0.9. So therefore, the probability of z less than m is now 0.9. Yeah. Okay, this is only the first part. Now, I will highly encourage you guys to draw it out. When you draw out, you understand better, right? And you can let this be m, let this be p, this is also p, so we add up. The total value is 10p. 10p equals to total probability, which is 1. Then you can solve for p. Okay, next, I'm finding the value of m. So this part here, we need to use our mathematical table, right? Or a calculator. So p z more than m is 0.1. So we can use our table. All right. So 0.1, you have to slowly find from the mathematical table here. 0.1. Here you're given the probability. You're finding the z value. So we take a number slightly more than 0.1, which is this one. So this is 1.28. Now, the thing is, I need to subtract 3 from here. But I don't have 3. I have 2 or 4. So it works like this. 0.1003. I either subtract 2 to get 0.1001, or I subtract, this is 1003, or I subtract 4 to get 0.000999. Yeah, so these two both are the closest. So when you read 1.281 or 1.282. So both answers are still okay. But I know you'll be thinking, which one should I take? Well, if you have this calculator, we can use this function. This is the most accurate way. You press mode, take 7. All right. Go to number 3, inverse norm. Your area is 0.1. And what I got here, your standard deviation is 1, mean is 0 because it's a standard normal distribution. What I got here is 1.282. Yeah, it's actually closer to 1.282 than 1.281. But if you leave your answer as 1.281, it's still okay, right? But think about it, this calculator, it will give us negative, right? Because it's actually calculated measure from the lower tail. Yeah, whereas when you use the table, it's based on the upper tail here, the upper tail probability. All right, coming back to this question. So it's okay to use from our table, right? You can say from the table, your m is 1.281, or you can say 1.282. Both are fine, but I've already shown you that if you use this mathematical table, use this calculator, you will get 1.282, yeah, which is a more accurate answer. Okay. All right. Okay, so the next one is Form 5, Chapter 1, Circular Measure, Question 5. So we're given a semicircle OECD with center O as a right angle triangle ADE. So this length is 6, radius is 6, so this is also 6. You are supposed to find angle EAD in radian. So we let EAD be theta, if you like, and we can see this is a right angle triangle, and this right angle triangle has the length here 10, this is 12. So your opposite is 10, your adjacent is 12. So to find angle theta, we can use tangent. Tangent is opposite over adjacent, right? So use your calculator in radian mode. Now, I know some students will use degree, then it convert to radian. So I don't recommend that, because if you use degree convert to radian, normally we use pi as 3.142, which is not accurate, right? Yeah. So why don't we just change directly? Shift mode to radian, shift tangent, 10 over 12, and you'll get the answer exactly in radian, 0.6947. Yeah, 0.6947. And 4 significant figure is enough. Yeah, don't have to do more. Okay, then I want to find length of arc CD. CD is this arc. To find the length of this arc, I must first join this together, right? I need to find this angle. Now, we know angle subtended at the center is always double angle subtended at the circumference, right? So this is your center. This is your circumference, right? But so happen your circumference, you can see this line is exactly a straight line, the diameter. So it doesn't matter. My alpha is just double. Okay, let me just write angle COD, or your alpha is just 2 times of your theta, 0.6947. Now, up to you. You can do one shot, or you can calculate the angle first. Yeah, 0.6947, you times 2. I got 1.389. Yeah, 1.389. Okay. Now, if you do directly, then you will get, if you will have an additional 4 at the back. But if you don't want, you do one by one, it's also okay. Your answer will be slightly different when you use S equals R theta. Your R is 6, theta is 1.389. In this case, is your alpha, right? You notice with the 4 at the back, you times with 6, you will get 8.336. But if you don't put that 1.389, you get 8.334. Yeah, I think both are okay, because it's already quite accurate. Maybe you're using 4 significant figure, it's fine. Yeah, don't have to put more. Okay, but you can actually like sub in, as I say, sub in directly. Okay, next one. How do you find area shaded region? Okay, to find area shaded region, basically we need to take this triangle, the big triangle, minus this triangle over here. Maybe I highlight for you this triangle, and then you minus your sector of circle. All right. Now, this triangle, we can use half AB sine C here, because these two are equal length, 6 and 6. But I need to find angle AOC. Well, your AOC, you can call it beta. AOC is your beta, up to you. You can just write AOC here. It is just 180 minus alpha, 1.389. Okay. 180 because it's a straight line, but I can't use 180 here because this is in radian. Normally in SPM, they'll ask you to use 3.142 minus 1.389. Guys, my answer is 1.753. Yeah, 1.753. Okay, now this is in radian. So then you have to minus one more sector of circle, the yellow one. Okay, my area shaded region, let me use half times base times height. My base is 12. My height is 10 minus half AB sine C. Yeah, since your AB are the same, they're both 6, right? This is 6, this is also 6. So I just take 6 square sine 1.753 radian. Then I minus half R square theta. In this case, your alpha is 1.389. Okay, let's count, right? Use your calculator. Let me do it here. Let's take half times 12 times 10 minus half 6 square sine 1.753. All right, and then make sure your calculator is in radian mode, because this is in radian. Yeah, whenever you sine cos tangent in radian, it is important that your calculator is in the same mode, radian mode. Okay, 1.389. Okay, I got 17.295. If you round correct to 4SF, is 17.30. 17.30. All right. Question number 6, the first part A, is a question from Form 5, Chapter 3, Integration. So diagram shows a front view of a door. So BAC is part of a graph y equals to 9 minus x squared over 6. At the highest, A is the highest point from DE. Find the surface area of the door. So actually, if you map this onto a Cartesian plane, it looks like this. This is a curve. All right. This is a horizontal line. And let me extend here. This is your x-axis. This line is y equals to 8.5. This one is 9. Sorry, my curve is a bit too much. Curve too much. This because this length is only 0.5. All right. So this is a y-axis. Now the thing is, I need to find what is my x value here, right? So we know this curve is 9 minus x squared over 6. When your y is 8.5, let us sub inside 9 8.5 is now 9 minus x squared over 6. So let's bring it over. X squared over 6 is 9 minus 8.5, which is 0.5. 0.5 times 6 is now 3. When we square root, there is a plus minus 3. So that means that there are two values here. One is positive root 3. One is a negative root 3. Okay. All right. Now, why do I need to do this? Because I need to find the area. Yeah. Remember, area under the graph can be calculated by using integration. But for me, I can see that they are double. This area, they are actually symmetrical. So rather than finding integration from -3 to 3, I would just take 2 times of integration 0 to such 3, and your function is 9 minus x squared over 6 dx, right? So I'll just leave a 2 outside. When you integrate 9, you get 9x. When you integrate this, you get x power 3. There's a 6 here, you multiply by 3. Now, in fact, we can just write this as 18. Yeah, just write this as 18. And then lower limit 0, upper limit such 3. Let us substitute the upper limit first. So this one is 2, keep it outside. 9 such 3 minus such 3 power 3 over 18 minus 0. Okay, just so you know, such 3 when you power 3 is actually 3. Okay, maybe it's better for me to write like this. Such 3 power 2 plus 1, which is such 3 power 2 times such 3. That gives us 3 such 3. Yeah, such 3 squared is just such 3. Now, why? Because I want to leave my answer in such form, right? We can actually leave in decimal form, yeah, because question didn't specify, but I'll just leave it as 3 such 3 over 18, which we can cancel. When you cancel these two, you're left with 6, right? 9 times 3 times 6 is 54. 54 minus 1 is 53. So this will be 53 such 3 over 6. When you divide it, you get 53 over 3 such 3. Now, you can leave it in this form, or you can change to decimal, right? Change to decimal, 53 over 3 such 3. My answer is 30.6. Yeah, 30.60. This will be unit. This is feet, feet, square feet. Okay, square feet, you can write as F, square feet, right? Or feet with a square. All right. Okay, now to double check your answer using integration, your calculator has this integration function. We can type 9 minus alpha x squared over 6. Your lower limit is 0. Upper limit is 3. Whatever we get, you need to times 2. Okay, I just put the 2 extra outside. Right, okay, let me just put the 2. Okay, I tell you, I just calculate this first. I times 2. Yeah, I got 30.60, right? Yeah, round off is the same answer. Okay, so this is only the first part. Let's do the second part. All right, second part is also from the same chapter, integration. All right, so we have part of a curve y equals to gx and a straight line y equals to fx. So now the integration of 0 to k gx dx. So since your gx is a curve, this is y equals gx. 0 to k, that means this is 0 to h, this is h, 0 to h, this is h here, this h here. Remember, integration 0 to h is area under the graph here. This area is now 6 units. All right, 6. Okay, maybe my 6 a bit thicker. I put a bit thinner. Yeah, 6. And you're supposed to shade the region. Oh, okay, I've already done that. Yeah, my region that I'm looking at is here. So you just shade it. Yeah, there you go. That's your answer. Yeah, for part A. Okay, then find the area in terms of N, in terms of M, Malaysia, for the region bounded by the y-axis, gx, y equals gx, y equals fx. Okay, area bounded by the y-axis. So let me highlight for you. This is your y-axis. Y equals gx, and y equals fx. This is fx. Fx is a straight line. So the area that we are talking about is this yellow region. Yeah, we're finding the yellow region. But the problem is we are finding this in terms of m, right? That means there's no h. I can see from here, to get the yellow region, I need to take a trapezium minus integration. Yeah. Well, this region we know is 6 from the first part, right? But trapezium is a bit of a problem because we don't know your value of h. We want your answer in terms of m, no h, right? So you can see the length from here to here is h0 to h. This is h, right? All right. This one is 2m. Can you see? 2m. This is m. So let me write here m. So if you use area trapezium, your answer will be in terms of h and m. But I don't want h, I want m. So I need to find a relationship between h and m. Well, what we can do is we can use gradient. Now, if you look at the diagram here, okay, let me rub this off. Too many lines, a bit confusing. We know this point and this point. We can find the gradient, right? So for part B, let me do it here. My gradient, well, gradient, I know it's a bit confusing because this is also m. All right, should I say my gradient? When I compare my gradient, let's do y2 minus y1. Y2 is 2m minus y1, which is m. X2 minus x1, which is 0 minus h. Then I can also take the whole thing. Yeah, I like to use negative y-intercept over x-intercept. My x-intercept is 8. My y-intercept is 2. Yeah, negative y-intercept over x-intercept to find my gradient. Now we can cancel this off. This is now m over h with the negative. This is negative 2 over 8. We can cancel m over 4. Cancel negative m. My h is 4. All right, so I got the value of h. H is 4. So I know that if h is 4, your area of your shaded region will be half. Use area trapezium, sum of parallel side, 2m plus m times height, which is 4, minus area of your this under the curve here, which is 6. This would be, let me cancel this 2. Cancel it with 2. 2m plus 1m is 3m. 3m times 2 is 6m. My area is 6m minus 6 square unit, right? You don't write the unit, is fine. Yeah, leave it at 6m minus 6. Okay, question number 7a. This is from 4, chapter 2, quadratic function. Okay, take note there is a few mistakes in the question. All right. Number one, this is supposed to be a square. It's a quadratic function, and this is supposed to be a plus. Otherwise, a linear function. And if it's a minus, then it will not intersect. If your a is less than 0, right? For general, we call this an intercept form. If your a is less than 0 and your q is less than 0, so the whole graph will be below the x-axis. It will not intercept, right? So, and if you check the marking scheme, it's supposed to be a plus. Yeah, so take note that there's a plus here and there's a square here. So first of all, maybe I'll do it here. I'll do it here. You're supposed to express this function in intercept form. Intercept form means, or we say factor form. That means you can put the x minus alpha, x minus beta. Now, it doesn't matter your a, you may have an a outside, inside. So that means we are talking about this, the roots alpha and beta. Yeah. Okay. So number one, we may have to expand this first. Your fx is now minus 2. Expand the bracket, x squared, 2ab. I hope you know that a plus b squared, when you expand, is a squared plus 2ab plus b squared. If you have x plus 1 over 4 squared, it's x squared plus 2x 1 over 4 and a 1 over 4 squared. So this will be 4 and 2 cancel up with 2. So this will be a 1 over 2x, and a 1 over 4 squared is 1 over 16. Then you plus 49 over 8. All right. Now, next, let us expand this bracket. This will be negative 2x squared. All right. This negative I just multiply in 1 by 1. So I will get minus x plus 1. Okay, it's still a minus, minus 1 over 8. Yeah, minus 1 over 8 plus 49 over 8. So this will give us negative 2x squared minus x plus 49 minus 1 is 48. 48 over 8 is 6. Okay, we can actually factorize from here, but I know a lot of people find it a bit hard to factorize if your coefficient of x is negative. So what we can do is we can take out the negative. This will be 2x squared plus x minus 6. Yeah, it's easier to factorize from here. Now look at this number. This is 2 times 6. 2 times 6 is 12. Factor of 12, 12 and 1, 6 and 2, 4 and 3. To get 1 here, this is 1x, I should use 4 and 3. So let's put double bracket. Yeah, let's put double bracket. Negative first, double bracket. So one of them must be 4, one of them must be 3. Now, if I put 2 here, that means my 4 should come from this, 3 should come from here. To get 4, I put a 2. To get 3, I put 3 here. 4 should be positive, 3 should be negative. There you go. You can leave your answer like this. I know some students, they go and expand or they multiply instead they factorize 3 minus 2x. When you times the negative inside, you only times in one time with the first 2. You don't go and times both of them. So you can write 3 minus 2x with the x plus 2. Yeah, this is correct. This is also correct. Yeah? They are both what we call quadratic function in intercept form. Okay. Now let's look at part B. This is a different question altogether. Your quadratic function fx is now negative x squared plus 4x plus 12, where a is now negative 1. So make generalization on the shape of the graph when a changes to negative 8. Now we know this is a maximum graph, yeah, but this one is probably something like this. You don't have to sketch accurately. So what we know is that the moment your magnitude of your a here is now bigger. Magnitude, I'm talking about bigger magnitude here. Previously your magnitude is 1. Now your magnitude changed to 8. So the graph actually becomes a lot sharper. Yeah. But actually your axis of symmetry will also change a bit because axis of symmetry depends on b over 2a. Your a changes, axis symmetry will also be shifted. Yeah. Okay, but anyway, we're not talking about that. We don't need to talk about axis symmetry. What we are concerned about is the shape of the graph, not the position of the graph. So we say that the width of the graph decreases. Yeah. Before this, your a probably, when your a is negative 1, it probably looked like this. The moment you change to negative 8, it will actually shift a little bit, shift up a little bit, or left, right a bit, right? So your a is negative 8. It looks something like that. Yeah, you don't have to draw. We just have to mention that the width decreases. All right, this is B Roman 1. How about B Roman 2? If the graph moves 5 units upwards, determine the maximum point. Okay, so we have to first complete the square to find out what is the original turning point. Or some people, they at first, then they complete the square later, also can. All right, okay, I tell you what, I'll just add 5 units upwards. That means we are adding 5 to the last digit here, 12. This gives us 17. All right, so step 1, I do that. Step 2, I'm going to complete the square. Now, remember, you cannot complete the square unless the coefficient x squared is 1. If it's not 1, you factorize it, take out negative. 4x, take out negative 1, becomes negative 4x. Keep the 17 outside. I always like to keep the 17 outside because it's not involved in the process of completing the square. And when you complete the square, the technique is this. We take half of negative 4. What is half of negative 4? Negative 2. And we square it. And immediately we take this negative 2, we square it, we get 4. All right? But we always minus. Keep the 17 outside. Now, why do I do that? Right? Because when you were to expand, now don't have to expand, but if you were to expand, this is minus 4x plus 4. You notice when you expand this bracket, you have an additional 4. We need to subtract the 4 to balance it out so that when you cancel this, you're getting the same thing as the expression above, right? So generally, even you can call this a formula. Yeah, it's more like a technique than a formula. That is, generally, if you have x squared plus bx to complete plus q, if you like, to complete the square, we take half of b. In this case, we write, b over 2. We square it, you minus this off, the same thing off, and then you plus q. Q is not involved, just leave it outside. So that's what I did here, okay? And then this negative, you have to multiply back inside, minus x minus 2 square plus 4 plus 17. I multiply this negative back inside. And from here, I got 21 minus 4 plus 17 is 21. So we're supposed to determine the coordinate, the maximum point. Okay, we can see from here, your maximum, we know is maximum because your a is less than 0. Your maximum is the one outside the bracket, which is 21. Your fx can only be 21. Yeah, your fx can only be 21 if this is 0, if your x minus 2 is 0. Okay, the x minus 2, when I let it be 0, my x is 2. X equals to 2 is called your axis of symmetry. But we're supposed to find the maximum point, guys. Maximum point, we write x first, which is 2, followed by your y, which is 21. There you go. That is your coordinate of maximum point. Right? Okay, question number 8 is from chapter 7, coordinate geometry. Okay, so here we have 2 points with a coordinate of E2, 4, 8, 6. Okay, maybe I just do a sketch. Doesn't matter, a rough sketch we do. This is 2, 4. This is F8, 6. C2T lies on perpendicular bisector of EF. Okay, what is a perpendicular bisector? A perpendicular bisector is a line that cuts this given line into 2 equal half and perpendicular to it. Now, it is given C lies on this point. So I put a C here. C is, let me write C to T. All right. So you're supposed to find the value of T. Okay. What we can do, number one, we know that the gradient of these two lines multiplied together must be -1, right? But I need to find the midpoint. Okay. So I need to find the midpoint of EF. So let M equals to midpoint of EF, which is 2 plus 8 over 2, 4 plus 6 over 2, and this gives us 5, 5, 5. Yeah, your C is 5, 5. Okay, now next, sorry, your M is 5, 5. This is M. Next, what we can do is we take gradient of EF, we multiply with gradient of CM or MC, right? The result must be -1. So for EF, we take y2 minus y1, x2 minus x1, multiply with MC, which is, I will take t minus 5, 5, 2 minus t, 2 minus 5. You can do the other way around. I'm taking y2 minus y1, x2 minus x1. I take t first. If you write 1, take 5 minus t, divide 5 minus 2, also can. The result is -1. So this gradient is now 6 minus 4 is 3. Sorry, it's 2. 2 over 6 is 1 over 3. 2 over 6 is 1 over 3. This is t minus 5 over -3. The result is -1. 3 times 3 is 9. There's a negative. I carry over here. Negative times negative is positive. Just bring the t over, bring the 5 over t is 9 plus 5, which gives us 14. Okay, first part, not difficult. Okay, second part. A point R moves from two fixed points P and Q such that distance PR is half distance QR. So this is from equation of locus. Distance PR is half distance QR. So remember, R is a moving point. A moving point, we always use XY. So let's use the formula for distance. PR, I'll take X minus PP is 1, 0. Can you see P is 1, 0 here? So we use X2 minus X1. Your X2 is XY, right? And Y2 minus Y1, 0. This is half. QR, I will use X minus 2 square. So your Q here is 2, negative 3, plus Y minus minus 2 is a plus 2, plus 3. Y minus minus 3, so it's a plus 3. So square both sides. Okay, let me show you. By squaring both sides, we can get rid of the square root. And immediately I expand this. Yeah, I hope you can expand this very quickly. A square 2ab, 2 times x times negative 1 is negative 2. Negative 1 square is 1. Then you have a y square. This will be 1 over 4. This will give us x squared. 2 times x times minus 2 is minus 4x. Minus 4 square is 4. Then I have y squared. 2 times 3, 6 times y, 6y plus 9. All right, let's multiply over. So 4x squared plus y squared times 4, I put 4y squared. All right, then minus 8x plus 4. This will be x squared plus y squared minus 4x plus 6y plus 13. So bring everything to the left. 3x squared, 3y squared, minus 8 plus 4, minus 4. 6y, bring over negative 6y. 4 minus 13 is minus 9. The result is 0. Okay, so there you go. That's your equation of locus. Next question, question 9. This is Form 4, Chapter 8, Vectors. So here we have the length of vector k, which is 5 units, and the direction is opposite to vector 1 minus 2. Find the vector k. So we know when a vector is parallel to another vector, right? So the first vector k, if we say is parallel, is lambda times of the second vector 1 minus 2. However, this is exactly opposite, right? So we need to put a negative. For example, if vector A is going here, the opposite vector will be B, let's say. B is negative A, but it can be longer, can be shorter, right? Maybe B can be 3 over 2A, right? So that's why you need to put a lambda and you need to put a negative in front. So here the length is 5 units. I think it's best we just use magnitude, right? Now I know a lot of people will multiply inside, but you don't need to, right? You don't need to multiply inside. We can just keep the lambda outside. So magnitude of k is given as 5. So we keep the negative lambda here. We take the magnitude of 1 and minus 2, that is 1 square plus minus 2 square. Then we square root it. The result is 5. So negative lambda is now, this will be square root 5. Let me put the square root 5 here. 1 square plus 2 square. 2 square is 4. 4 plus 1 is 5. So we divide it. So lambda is 5. Divide surd 5 with a negative. Your lambda is negative surd 5. 5 divided surd 5 is just surd 5. So let's take this k negative surd 5 and sub inside. Okay, so sorry, because we put a magnitude, right? Sorry guys, I don't put the lambda, I don't put the negative here because your lambda is, magnitude is always positive, so we just leave the negative here. All right, this is surd 5. When you sub this inside, now there is a negative in front, so your k is negative, vector k is negative surd 5, 1 minus 2. When you multiply inside, it's minus surd 5 to surd 5. Okay, all right, that is vector k. All right, that's part A. Part B, let me continue here. So here we have a ship that X, right? It left port O when the sea was calm. The velocity is given by this. And at the same time, ship Y leave port B with the velocity of that. Position vector OP is. Okay, now, first of all, I need to explain to you the idea because some of you may not have seen this before. So let's say if a ship with a velocity of V, right? Velocity is position vector divided by time, right? So we multiply this over. This is TV equals to AB. AB will be OB minus OA. If I make OB as a subject, OB is OA plus TB, where B is your final position of the ship, of the boat, or things like that, and OA is your initial position. So basically, it's the initial position plus T times of the velocity. For example, let's say you have, this is point A, this is point B, right? So the boat, let's say OB is the position of the boat or position of the ship. So we initially go from O to A, then we go from A to B. Now AB is T times the velocity. So at T equals to 1, yeah, starting from here, it starts from point A, yeah, it may be here. At T equals 2, it may be here. T equals 3, it may be here. T equals 4, it may be here, and so on. So B is a moving point. B can be here, can be here, can be here, right? As the time goes by, the B position B changes, right? So an OB represent the position vector of your boat, or in this case, your ship. So you need to know how to use this formula. In IGCSE, they actually learn this formula, but in SPM, you don't learn this specifically, right? So some people don't know about this. So that's why I want you to know that this is your final position, this is your initial position, plus T multiplied with your velocity vector. Okay, so the first one is they gave us a ship X, right? A ship X actually left point at O. O is your origin. So that means that the velocity, the position vector, see, notice that after T hours, position vector of ship X is given by this. Actually, this is not Vx. This one's supposed to be OX. We should say OX. Yeah, this is supposed to be OX. Ship X, right? So your OX is actually starting from point O, but we can't say OO lah. We don't say OO, right? So it's just T times of velocity of your ship X. Velocity of ship X is 6I 8J. Now here, I just write 6I 8J. You can write in column vector. Yeah, in fact, column vector is easier. Then we're supposed to find the position vector of ship Y. Now remember what I said just now, ship Y equals to your initial position. Okay, read the question again now. Where's the initial position? Ship Y left port P with this velocity, and port P has this position vector. So we say OP plus T velocity of ship Y. Okay, this is your VY. Okay, your position vector of port P is 25I plus 10J. Then you plus with T, multiply the velocity of ship Y, which is minus 4I plus 4J. So let's expand and simplify this. So I'm just going to put the I together. This one you times in. So we have 25 minus 4T, group together the I, and then 10 plus 4T, group together the J. All right. Okay. Now, have I gotten this position vector of Y? Yes. Yeah, this answer. This is your position vector of Y. Now, next, find the time that ship X will, okay, I should use the word collide, okay, not breaking, collide with ship Y, yeah, they collide when OX is the same as your OY. Now, my OX, let's just expand this and write in I and J form, 6TI plus 8TJ equals 25 minus 4. 25 minus 4TI plus 10 plus 4TJ. So let's just compare one by one. Let's compare the I component. My I component is 60 and it's now 25 minus 40, right? So we say 60 equals 25 minus 40, bring over. 10T is 25, T is 2.5, meaning they will collide after 2.5 hours. But actually, we should show that both I and J are the same. Why? When your I value is the same, means they have the same horizontal position, but they must also have the same vertical position. So in this case, I'm going to compare my J component and my J component over here. So 8T is now 10 plus 40. Bring over 40 is 10 10 divided by 4, still 2.5. Yeah, you can see here, they have the same I and j component, meaning when would they collide? Yeah, they will collide after 2.5 hours. All right. Okay, question number 10. This is from Form 4, Chapter 4, Indices, Surds, and Logarithm. Okay, let me start with part A. This is a logarithmic equation. Now, you notice that they have different bases. This is log base 2, x squared minus 4, and then you have plus 1 here. Now, this one doesn't have any logarithm, right? Now, you can see this is base 2. This is base surd 2. So, it's always easier to change to base of a number than the base with a surd. So, I'm going to introduce log 2 because I want to change everything to base 2. And why do I use log 2? Because log 2 has a value of 1. So, it's exactly the same as this value here. As for the second one, I'm going to change the base. Now, remember, formula for changing base is given as this. Log base AB is now log. We use the new base C and C. Original number B stays on top. Original base A right below. So, in this case, we write log base 2. Log base 2. Your original number 2 minus x stays on top. Original base surd 2 right below. Okay, next, we're going to combine this as a single logarithm. Remember, in logarithm, when you plus together, for example, log base ax plus log base ay, when you combine them, it becomes x times y. We write as a single log. So in this case, we have a 2, I put in front, with the x squared minus 4. Whereas this one is going to give us log base 2, 2 minus x, log 2 square root 2 is just half. Okay, I hope you know this as well. If I say log a power n is just n. So if you have log 2 square root 2 means 2 power half, your answer is just half. Well, if you're not sure, you can use a calculator. Actually, this calculator can do this because you have this button here, log 2 with a square root 2. There you go. Answer is just half. So we can just write this as half. And I would like to either you multiply over or you flip it up. I think you flip it up is easier. So here, let me write log base 2 and I expand this 2x squared minus 8. When I flip this up, it becomes a 2 log base 2 minus x. Now, also, yeah, I'm writing down a lot of formula for logarithm, just in case you don't know. If I have log base ax to the power of m, we can bring the power up log base ax power m. So I'm going to bring this power up, so we'll get to 2 minus x squared. Now, the idea of getting rid of logarithm is that if I have a logarithm, a single logarithm on the left, a single logarithm on the right, I can just compare them. So we say 2x squared minus 8 is now 2 minus x with a square. Okay, so let me continue here. Expand this bracket here. You will get 4 minus 4x plus x squared. Bring everything to the left. So 2x squared minus x squared is x squared plus 4x minus 12. The result is 0. So from here, let's double bracket factorize. Factor of 12 to get 4, I should use 2 and 6, right? I want 4, right? So this is 6, this is 2. The bigger number 6 is a plus, smaller number 2 is a minus. So x is 2 or negative 6. When it comes to solving equation involving logarithm, you always have to double check your final answer whether it is valid or not. Now you notice in this case, if I were to put 2 inside here, 2 minus 2 is going to give us 0, right? When x is 2, your log, doesn't matter whether you use the first one, second one, but you notice even you put the first one here, 2 squared is 4, right? Maybe I put the first one here, 2 squared is 4. This will give us log base to 0, which is what we say is invalid or is not a real number. You cannot evaluate log base to 0. Log base to 0 is undefined, right? But when x equals to negative 6, now this is not a problem. Although you say it's negative, or what happened with negative, when you put inside here, or you put inside here, the negative will cancel each other out, right? The first one, when you put the negative, right, what happened? Negative 6, when you square it, it becomes 36. You minus 4, you get log base 2, 32, which is the valid answer, all right? So therefore, we can say that this one is a valid answer, all right? Just put a bracket valid. So therefore, your final answer, x is -6. Only one answer, right? Okay, remember, you need to double check. May have to reject one answer. Okay, second one, part B. We have area rectangle is 3 plus set 3. Given that length is 2 plus set 3, find the width in set form. So this is your length, 2 plus set 3. The width, I don't know. I call it x. And this area is 3 plus set 3. So we know length times breadth gives us the area, 3 plus set 3. What I need to do is to take this area, divide by the width. Okay, here we have to rationalize the denominator by multiplying top and bottom with 2 minus set 3, which is conjugate. So let's expand. The one on top, we can expand 3 times 2, 3 times set 3, 2 times set 3, 3 times 3. So let's expand one by one. This will be 6 minus 3 set 3 plus 2 set 3 minus 3. Divide. Your denominator is 2 plus set 3, 2 minus set 3. When you expand, 2 square is 4, set 3 square is 3. Let's simplify this. 6 minus 3 is 3. Minus 3 plus 2 is 1, minus 1 set 3 over 1. Therefore, my x is just, or the width is just 3 set 3. Now we can always use a calculator to validate our answer. Like you know that we can, if you have this calculator or even the black one, we can take 3 plus set 3 divide by 2 plus set 3, and then there you go, 3 minus set 3. But you can't do it directly. Yeah? You need to show your working. This is for you to double check. Okay, question 11. This is the trigonometric function, form 5, chapter 6. Okay, this question has a lot of error. Okay, so first of all, the first error is that tangent A over 2 is not 1 minus sine A over cos A. Well, I can show to you, I can prove to you. If you start from tangent A over 2, we know tangent A over 2 is sine A over 2 over cos A over 2. All right. So there are actually two versions. We can actually multiply top and bottom. So I tell you what, I multiply top and bottom with sine, right? Sine. So this will be sine squared A over 2 divided by sine and cos. We write this as sine and cos. And then I add a 2, right? Why do I do that? Because I want to change the denominator to sine 2a. In this case, sine a. We know that sine 2 theta is 2 sine theta cos theta. If you have sine a, this is 2 sine a over 2 cos a over 2. And you also know that if you say cos 2a theta, right? Cos 2 theta is 1 minus 2 sine square theta, right? So if you make this as cos A, this is 1 minus 2 sine square A over 2. Now, when I bring this over, my 2 sine square A over 2 is now 1 minus cos A. So this is supposed to be 1 minus cos A over sine A instead of 1 minus sine A over cos. It's wrong, right? So, and if you check the marking scheme, they also admitted that the answer is wrong. Okay, so so I'm going to make changes to make it valid. Okay, so number one, I'm going to change this, right? Otherwise, this question becomes invalid. Is 1 minus cos A over sine A. Okay, number two, right? I cannot use tangent 30 because tangent 30 is not in this form. Tangent 30 is not in this form, right? Because we know you can actually use a calculator. Tangent 30, if you use calculator in degree mode, tangent 30 is actually set 3 over 3. There's no p in front, right? So in fact, I think the correct one should be tangent 50. Now this is actually a clone. We try to clone the question from SPM 2019. right? So which is something similar to this. So it's supposed to be tangent 15, 2 minus sec 3. All right. So sorry, we have to change this to 15. Okay. So let's start. Okay. Number one, we know, let's say you're given this, tangent a over 2 equals to this. We're supposed to, without using calculator, find the value of tangent 15. Yeah, this is 15. So we let a be 30. So your a over 2 will be 15. So let's sub inside. Yeah, tangent 30 over 2. This is, let me write here, tangent a over 2. So if your a over 2 is 15, so I'm going to write 15 here. This will be 1 minus cos 30 over sine 30. Now, cos 30, if you have this calculator, you can find that directly. If you don't have, you have to use a triangular method. Yeah, draw a triangular. Cos 30 is sec 3 over 2. So I'm going to write sec 3 over 2. Sine 30 is half. Yeah, sine 30 is half. This is 1 over 2. Now, I say this again. If you don't have the calculator, well, you need to draw a triangle. But even if you have the other calculator, right, the 570 ms, you can just type sine 30, you will get 0.5, which is half. So we just draw 30 here. Sine is opposite over hypo. My adjacent is 2 square minus 1 square square root, which is square root 3. If I know this is square root 3, I know this is 30, this is 90, this should be 60. I can find everything else, right? But you need to use a triangle, okay? All right. Coming back to this, what I'll do is I'll multiply top and bottom by 2, get rid of fraction. So I get 2 minus sec 3. There you go. Like I say, I can validate using calculator. Tangent 15 is 2 minus sec 3. Yeah, so this is the correct one. Okay, then hence solve this equation. Okay, again, we'll do some modification. Why? Let me explain why. If I put tangent A equals this, even if I change to a correct formula, now we have a problem because if this is cos A, right? You multiply over, you get 1 minus cos A. This will be cos A sine A, where you have 3 variables. I mean, 2 variables, but they are like, for example, 1 minus x equals xy. You can't solve this, right? We can't continue to solve this. So that's why we have to do some modification again to the question. All right, I'm sorry. We have to change this to a sine A, right? If it's sine A, it will work, right? You can actually solve it if it's sine A. Okay, so let me just change this to sine A. So we're going to use the result from the first part. Now, your tangent, okay, starting from tangent A over 2 equals to sine A. Your tangent A over 2 is now 1 minus cos A over sine A. Look at this one, the corrected version. So this is now sine A. So when you multiply over, your 1 minus cos A is now sine square A. Now, from the basic identity, we know that cos square plus sine square is now 1. So we can change everything to cos. We make sine square as a subject, bring the cos over. Sine square is 1 minus cos square. So we write 1 minus cos and 1 minus cos square inside here. So what we have is a quadratic equation. Just bring over cos square A minus cos A equals 0. Now what happened to your 1? Cancel, cancel. I'm just bringing this to the right. And we can factorize them by taking out cos A, left with cos A minus 1, right? So here your cos A is either 0 or 1. And we are solving for A between 0 to 360. For 0 and 1, right, I don't like to use reference angle because I find it's very slow. We can just sketch a graph. Now, the graph of cos, if this is A, this is y equals cos A. Cos is 1 at 0 and 360. Cos is 0 at 90 and 270. So in this case, the first answer here, cos is 0. The cos value is 0. That means here, you think this way, this is 0. Move across, your two answers are 90 and 270. For cos A equals 1, this is 1. You move across. First answer is 0. Second answer is 360. So we say A is 0 and 360. So all in all, you have 4 answers. 1, 2, 3, 4. Okay? Okay, next question, question number 12. This is from 4, chapter 5, progression. So we are determining the number of terms and in this progression. Okay, so very simple. Your first term A is 2b squared. So this is an arithmetic. You can see it's arithmetic increases at a constant rate. So plus constant difference. Same common difference. You have a common difference here. You increase by can I say 5b squared minus 2b squared? This is 3b squared. All right. And your last term Pn is now 92b squared. So remember, for the n term of an arithmetic progression, we use a plus n minus 1d. In this case, my a is 2b squared, n minus 1, my d is 3b squared. The outcome is 92b squared. Now, actually, the p square is a bit annoying. You know, you can actually divide by p square, get rid of the p square, just cancel all the p square off. Oh, I don't want the p square, right? So that make our life easier. 2 plus n minus 1 times 3 equals 92. Now, for me, I will take 92 minus 2 divide 3 plus 1, right? Bring over minus, divide, and then plus 1. Okay, do one by one. Okay, use your calculator. 92 minus 2, which is 90. 90 divided by 3, 30. 30 plus 1, 31. Your n is 31. All right. Next, we have the ninth term of an arithmetic progression is 36, and the sum of the first 19 term is 760. Yeah, determine the number of the sum of the fifth term after the ninth term. Yeah, the fifth term after the ninth term. Okay. All right. So I think the first thing I need to do is we can say that the T9 is 36. So we can use a general formula, A plus n minus 1, which is 8. D, this is now 36. Yeah, call this equation 1. The sum first 19 term is S19 is now 760. Now we know the formula for Sn is given by n over 2, 2a plus n minus 1d. So my n is 19 divided by 2, 2a, n minus 1 is 18 times d. The result is 760. We have to form two equations and solve for a and d. Okay, for me, I take the half and times in because 2a times half is a, 19, 18 times half is 9. Whereas this 19 over here, right, I'll bring it over, bring it down. So I'm taking 760 divided by 19, yeah? 760 divided by 19. So use your calculator, 760 divide 19, you get 40. So this is my second equation. So let's take equation 2 minus equation 1. A minus A disappear. 9D minus 8D is 1D. 40 minus 36 is 4. D is 4. Then you sub inside equation 1. My A plus 8 times 4 is 36. 36 minus 32, the difference is 4. Okay, I got my A, I got my D. I want to find the sum of the first 5 term after the 19th term. So now we know when we say 19th term is T1, T2 until T19. In fact, we already know this. This is the sum of the first 19 term is given as 760. The next 4 term will start from T20. The next 5 terms, T20 to T24. Yeah, 0, 20, 21, 22, 23, 24. You can use your finger to count if you're not sure. You're supposed to find the sum of the next 5 terms. Well, this sum is S24. So to find this value, we need to take S24 minus S19. Now, S24, we can use the formula 24 over 2, 2a. Since my a is 4, n minus 1 is 23. My d is also 4. And my S19 is 760. Okay, so let's use our calculator, guys. Calculator, 12, bracket, 2 times 4 is 8. 23 times 4, whatever I get, 1,200. I minus 760. Okay, my answer is 440. All right. Okay, question number 13. This is Form 5, Chapter 2, Differentiation. So here we have 40 spherical marbles with radius of x and 60 spherical marble with radius of y. X plus y is now 15 and x is not equal to y. You're supposed to find the value of x and y, but the total volume is minimum. Okay, so first of all, your volume. You know volume of a sphere is 4 over 3 pi r cubed. All right, so you have 40 sphere with a spherical marble, right? You multiply 4 over 3 pi with the radius of x, so x cubed. And then you also have 60 spherical marble with radius of y. So, but the thing is, I don't put y here because we know x plus y equals to 15. We want to reduce it to only one variable, so I put 15 minus x here. And this is power 3. Okay, let's simplify this. 40 times 4 is 160 over 3 pi x cubed. This 60 I can put together, I can cancel 60 and 3 left with 20. 20 times 3 is now 80. So it's 80 pi 15 minus x cubed. All right. Now, we know to have minimum maximum, your dv dx must be 0. First, let us differentiate. Bring the power 3 down. 3 and 3 cancel. Left with 160 pi x squared. Whereas the second one is a composite function. Now you bring the 3 in front. This 3 times 8. 80 is 240 pi 15 minus x. Reduce the power by 1. Let's differentiate inside. Negative 1. Remember, whenever you have bracket, yeah, we have to differentiate inside the bracket. So this is 160 pi x squared minus 240 pi 15 minus x bracket square. Okay, so we can straight away let dv dx be 0. Yeah, we're supposed to solve for x. Okay, we know at the minimum dv dx is 0. Now I don't like the pi, and I think we can actually divide this. So I divide by 80 and pi just to simplify this. This is 2x squared. 160 divided 80 is 2. 240 divided 80 is 3. The pi cancel out. So this, I can expand this bracket. This will give us 5 squared, 15 squared is 225. 2 times 15 is 30 x squared here. Let us expand the bracket to x squared. 225 times 3 is 675. And 30 times 3 is 90x minus 3x squared. The result is 0. Just minus them and bring everything to the right. Yeah? Okay, if not, you do a bit slower. It's okay. We put negative x squared plus 90x plus 675. The result is 0. Okay, bring everything to the right hand side. Okay, to make x squared minus 90x minus 675 equals 0. Okay, well, let me see if I make any mistake here. No. Now, I like to complete the square. You can use quadratic formula minus b plus minus square root b squared minus 4ac over 2a. Because I look at it, I can't actually factorize this. So I like to complete the square. If you are more comfortable with this, go ahead. To complete the square, I take half of 90. Half of 90 is 45. Then I square it. And 45 square, let me see, 45 square is 2025. So minus 2025. Then you minus 675. All right. Okay, 2025 plus 675 is 2. If you, wait, let me see. You have to minus. Okay, this part here is a minus. Did I make a mistake here? This is minus, right? Yeah, this is a minus here. This one is a plus. Sorry, yeah, this is a plus. So 2025 minus 2025. Yeah, minus 2025. You plus with 675. It will give us 1350. So let me write x minus 45 squared minus 1350. I bring it over. Okay. And then from here we square it. Yeah, every time we square it, we should put a plus minus, right? I know some of you may say this is very long, you rather use quadratic formula. Please go ahead. But when I use this, usually I will skip some of these steps because you don't need to write every step like this. Okay, so we're going to work out the two possible value of x. The first one is 45 minus 1350, which gives us 8.258. Yeah, 8.258. Now, the second answer, just change the minus to plus. I got 81.74, 742. 81.742. Now, we know x has a maximum value of what? 15, because they say x plus y is 15. It can't be more than 15. So since x is less than 15, x has to be 8.256. And I still need to find the value y. Yeah, I know my y is 15 minus x, 8.256. All right. Wait, did I say 8.256 or 8.25? Maybe I've written wrongly. This one is a minus 8.258. Sorry, it's not 6, it's 8. This is 8. This is 8. So you will get 6.742. Yeah, let me just do 15 minus answer 6.742. Okay, so I got my x value and my y value. Right. Okay, question 14. This is from 4 chapter 6 in your law. Okay, the first part, you're supposed to sketch the graph of ax squared plus b, given that a is negative. You're sketching based on y versus x squared. So that means your horizontal is x squared, vertical is y. So meaning this is your big Y, this is your gradient, this is your big X, this is your C. So I know my gradient is A, and A is less than 0, so it's a negative gradient. I know B minus y-intercept, yeah, y-intercept is more than 0. So the straight line that you have to sketch looks like this. Okay, you can sketch anywhere, any direction. So, yep. And this is your y-intercept, which is B. I guess that's about it. We don't need to do anything else, right? You just have to show that it says negative gradient and the y-intercept is B. All right. Based on the graph, what is represented by A and B? We just say A is your gradient. A is the gradient. Okay. And what's your B? B is the y-intercept. That's all. All right. Okay, next one, part B. So diagram 13 shows the graph of y equals to x squared plus mx. Based on the graph, a table of values of y over x against x is obtained, shown in the table. So calculate the value of MEK. Okay, so this is a graph that we haven't converted to linear form. So we're going to convert this to linear form. But first, we need to divide everybody by x, right? Because this is y over x. As I divide by x, this will be x plus m. Yeah, x plus m. So that means that we can rewrite this as your big Y. This is your big Y. Your gradient is 1. I know the gradient itself is m, and this is also m. It's a bit confusing here. This is 1. This is your m, this is your x, and this is your c. Your y-intercept is m here. So we say that your y, okay, well, I can find m first, right? Yeah, maybe I find the m from here. From this part, maybe you find m from here is easier. We sub in -4 and 0. Based on this equation, your y is 0, your x is -4, you square it, m times -4. So this is 16 minus 4m equals 0. 4m is 16, m is 4. Yeah, maybe it's better I do this first so I can find the value of m from this graph. So if my m is now 4, my straight line is now y equals to x plus 4. So we already know that the gradient is 1. Yeah. Okay. Now, why do I do this? Why do I convert to this one? Because I want to find the value of b and k. Yeah. This one, again, a bit tricky here because your x is written below, y written on top. Most of the time, we write x on top, y below. So we need to sub in the coordinate one by one, starting with p. Your x is p, your y is -5. So we put -5 equals p plus 4. We find p is -9. Then we sub in the second point. The second point is -2k. Your y is k. Your x is -2. My k is 2. There you go. You got the values of m, p, and q. Okay, question number 15, the last one. This is system of equation from 4 chapter 3. So Fifi is a chemist, has 3 types of solution. The first solution has 10% acid, second has 40% acid, third solution has 60% acid. Okay, so one day Fifi intends to prepare solution 3 types. With these three types of solution, she wants to prepare 500 liter with acid concentration 45%. The available amount of 10% solution, acid solution is twice 40% acid solution. Okay, I know this one is a bit confusing here. So we have a 10% acid solution, which we're going to call it X. We don't know what's the volume, all right? The second one is 40% acid solution, which we're going to call it Y. The third solution has 60% acid, we're going to call it Z. Okay, so the first part is maybe we say that when you combine them, right, the total solution, acid solution that you have is 45%. All right, okay, so that means the first one, 10% is 0.1. Okay, 40% is 0.4 of the volume Y. And the third one, 60% is 0.6 of the volume Z. And this total acid that I combine, it will give us 45% concentration of your total volume. Now, your total volume is 500. So I times with 500. Yeah. So we're talking about the total volume of acid in liter. So let's simplify this. I know this is a bit annoying. I don't like decimal. So we can multiply by 10. So as I times 10, this is x plus 4y plus 6z. Okay, so we shift the decimal point, 0.45. You times 10 is, move over is 4.5. You multiply by 500. It gives us 2254. Okay, so this is my first equation. Perhaps I should form this as a second equation because the first equation, which is actually easier, or should I say in this case, the second equation, which is easier, total volume is 500. Right, this one is easier, 500. And the third equation that we have is this. The 10% solution, the available amount, available volume is twice 40% solution. That means your x is 2 times of y. Yeah, x is 2 times of y. Okay, so how you want to solve this up to you. But I think since x is written as a subject, so we can sub equation 3 inside equation 1. Just to give you an x here. So your x is 2y plus 4y plus 6z is now 2250. 2y plus 4y is 6y. 6y, 6z is 2250. We can divide by 6. 2250 divide 6. Answer is 375. So y plus z is 375. First equation. Then we sub equation 3 inside equation 2. So your x is 2y, then another 2y and z equals 500. So 3y plus z is 500, equation number 2. Now let's take equation 2 minus equation 1. 3y minus 1y is 2y. Z minus z disappear. 500 minus 375 is 125. My y is 125 divided by 2, 62.5. So the volume of the 40% solution is 62.5. Then we just sub inside equation number 3. We find x. Your x is 2 times of 62.5, which is 125. And lastly, I want to find z. I think we can just sub inside equation number 2. It looks easier. Your x is 125. Your y is 62.5. Your z is an unknown. Total is 500. Okay, so let's take 500 minus 125 minus 62.5. Guys, I got 312.5. Yeah, 312.5. So the amount of, or should I say the volume of each solution, 40%, 10%, 40%, and 60% are given as 125. In this case, should be liter, right? Yeah, 62.5 liter and 312.5 liter. All right. We come to the end of the discussion of this paper 1. Yep, I hope you learned a lot in the process. Yeah, and thank you for watching. I hope to see you in the next video.